Did you know that all the gas giant planets in the solar system have solid surfaces? That is something they didn't teach you in school. Gas giant planets are known for their colossal size, immense mass, and striking appearance. However, what sets them apart from the rocky planets like Earth and Mars is their composition. Unlike their terrestrial counterparts, gas giants are primarily made up of gases such as hydrogen and helium, which do not solidify into a distinct surface. Instead, these planets have a gradual decrease in density as one moves away from their core. This means that there is an unclear boundary between the planet's atmosphere and the vacuum of space. As a result, astronomers had long believed that gas giant planets were entirely composed of gases and lacked any solid ground. However, recent discoveries have challenged this conventional wisdom. In fact, some scientists now believe that all the gas giants in our solar system have solid surfaces. The evidence for this intriguing idea has come from studies of Jupiter's moon, Europa, Neptune's moon, Proteus, and Saturn's moon, Titan. These moons have provided valuable insights into the internal structure of the gas giant planets and have led to the hypothesis that they may have solid cores surrounded by a mantle of liquid and an outer atmosphere. This discovery has opened up new avenues of research and has prompted scientists to reevaluate everything they thought they knew about these fascinating planets. But today, we will talk about how the Cassini-Huygens mission revealed the amazing secrets of Saturn. So let's start. The Cassini-Huygens mission was a joint venture between NASA, the European Space Agency, and the Italian Space Agency. It was named after the French astronomer Jean-Dominique Cassini, who discovered 4 of Saturn's moons and made other significant contributions to our understanding of the planet. The mission involved a spacecraft, Cassini, an American probe that orbited Saturn, and Huygens, a European probe that landed on Titan, Saturn's largest moon. The mission was launched in October 1997 and arrived at Saturn in July 2004. Cassini's primary mission lasted for years, during which it performed a series of close flybys of Saturn's largest moons, including Titan, Rhea, Iapetus, and Dione. During these flybys, Cassini collected valuable data and imagery that greatly enhanced our understanding of the moons and their surroundings. After the primary mission, Cassini continued to orbit Saturn until September 2017, providing an unprecedented view of the planet and its rings. Throughout its mission, Cassini made several remarkable discoveries about Saturn, its rings, and its moons. One of the most significant discoveries made by Cassini was the confirmation of the existence of 6 new moons around Saturn, bringing the total number of known moons to more than a dozen. The newly discovered moons are Pandora, Prometheus, Atlas, Pasiphae, Metis, and Aegeon. These moons are small and irregularly shaped, ranging in size from just a few miles to about 30 miles across. Their discovery provided valuable insights into the formation and evolution of Saturn and the solar system as a whole. Another major achievement of the Cassini-Huygens mission was the landing of the Huygens probe on Titan. Titan is the only moon in the solar system that has a dense atmosphere, and the only place outside of Earth where it rains. The landing was a significant milestone in space exploration and provided an opportunity to study Titan's unique environment. Hughes transmitted data and images back to Earth for over 90 minutes, before going offline as planned when it ran out of power. During its time on Titan, Hughes made several important discoveries, including the presence of lakes made of hydrocarbons and methane, and evidence of past or present geological activity on the moon. One of the most breathtaking sights that Cassini captured was the mysterious hexagon storm at Saturn's North Pole. This storm has been raging for centuries, and its exact cause remains unknown. However, Cassini's observations provided valuable data that scientists are still analyzing to try to understand this phenomenon. Overall, the Cassini-Huygens mission was a resounding success. It greatly advanced our understanding of Saturn, its rings, and its moons, and provided some of the most stunning imagery of the planet ever seen. The mission's legacy continues to inspire scientists and space enthusiasts alike, and serves as a reminder of the incredible discoveries that can be made when nations and organizations work together to explore the unknown. It would be a mistake to end this video without mentioning that Cassini also discovered complex organic molecules in the atmosphere of Titan. These molecules are the building blocks of life as we know it, and their presence on Titan suggests that the moon could be a potential candidate for hosting life in the future. Scientists hope to learn more about the possibility of life on Titan. when the Dragonfly spacecraft arrives at the Moon in the 2030s. During its mission, Cassini sent back hundreds of thousands of images of Saturn and its moons, revealing a world full of wonders and beauty. Some of the most famous images include close-ups of the planet S-rings, showing their intricate details and vast array of colors. Cassini also captured stunning views of Saturn's largest moon, Titan, including its hazy atmosphere and mysterious landscapes. The spacecraft's imaging science team carefully planned each image to capture the best possible views of the dynamic range, lighting, and composition of each target. Cassini carried 3 cameras, a wide-angle camera, a 10x optical zoom camera, and a 100x infrared camera, which allowed it to take pictures at various resolutions and wavelengths of light. Additionally, Cassini's imaging software used onboard artificial intelligence to identify interesting features and optimize the composition of each picture. The spacecraft's thrusters were even used to create artificial landmarks such as the letters NASA and greetings from Earth on the surface of Saturn's largest moon, Titan. These images captured by Cassini not only expanded our scientific knowledge but also inspired awe and wonder in people around the world. The mission's imaging team carefully planned each image to capture the best possible views of the dynamic range, lighting, and composition of each target. Cassini carried 3 cameras, a wide-angle camera, a 10x optical zoom camera, and a 100x infrared camera, which allowed it to take pictures at various resolutions and wavelengths of light. Additionally, Cassini's imaging software used onboard artificial intelligence to identify interesting features and optimize the composition of each picture. The spacecraft's thrusters were even used to create artificial landmarks such as the letters NASA and greetings from Earth on the surface of Saturn's largest moon, Titan. These images captured by Cassini not only expanded our scientific knowledge, but also inspired awe and wonder in people around the world. Before plunging into the planet's atmosphere, Cassini performed a series of maneuvers to ensure that it did not contaminate Saturn with Earth-based microbes. Despite these precautions, some scientists expressed concerns that the spacecraft's instruments could have been contaminated by Earth's bacteria. However, these fears proved to be unfounded, as no evidence of contamination has been found in Cassini's data. In the final days of its mission, Cassini made several close passes through Saturn's upper atmosphere, providing unprecedented views of the planet's weather and climate. During these passes, the spacecraft detected strong winds and storms that had never been seen before. In addition, Cassini found that Saturn's atmosphere was much more dynamic than previously thought, with winds reaching speeds of more than 600 miles per hour. These discoveries provided valuable insights into the planet's interior and its ability to generate heat. Unfortunately, communication with Cassini was lost as it plunged into Saturn's atmosphere, bringing an end to the mission. However, the data and images that Cassini collected during its lifetime continue to provide valuable insights into the planet and its moons. And if you think that's all, you'd be wrong. Before diving into the heart of Saturn, Cassini snapped a photo of the enormous storm that has been raging on the planet for centuries. The Great Red Spot is a massive high-pressure storm located in the southern hemisphere of Jupiter, and it is one of the most iconic features of the planet's surface. It has been observed for centuries and is large enough to swallow Earth whole. But despite its size and longevity, the exact mechanism that drives the storm remains a mystery. After more than a decade of observing Jupiter, Cassini's cameras have captured the clearest and most detailed view of the storm ever seen from Earth. The images show the storm's swirling clouds and the surrounding calm areas, providing a stunning view of the dynamic range and complexity of this mysterious phenomenon. Scientists are still working to understand the Great Red Spot and other storms on Jupiter, but Cassini's images are helping to unlock the secrets of these fascinating storms. The discovery that gas giants can have solid surfaces has opened up a whole new world of possibilities for astronomers. With this new knowledge, scientists can now explore the interiors of these planets using new techniques and models. For example, the European Space Agency's upcoming Jupiter Icy Moon Explorer mission, or JUICE, will study the gas giant Jupiter and its moons using a combination of remote sensing and in situ measurements. JUICE will carry a variety of instruments to measure Jupiter's gravity and magnetic fields, as well as the properties of its atmosphere and interior. By studying Jupiter's atmosphere, scientists hope to better understand the planet's internal structure and search for evidence of a solid core. Additionally, JUICE will explore 3 of Jupiter's largest moons, Ganymede, Callisto, and Europa, which are thought to have subsurface oceans of liquid water. The discovery of these oceans has raised the possibility that these moons could harbor life, and JUICE will search for evidence of any biological activity. Overall, the new understanding of gas giants and their interiors has opened up exciting new frontiers in the study of our solar system. With missions like JUICE on the horizon, astronomers are eager to uncover the secrets of these mysterious planets and their moons. And with that, we end our video. If you enjoyed watching it, please like and share it with your friends. Don't forget to subscribe so that you won't miss any new videos. Thanks for watching.